In the folding dark of ancient stone, there is a silence that speaks backward, not the absence of sound, but the presence of something lost, layers of time compressed into dust, then lifted by wind, then scattered across seas that no longer exist. The earth does not keep diaries. It does not archive its youth in careful order. Instead, it folds its past into itself, again and again, until the oldest chapters become whispers beneath new ground. Somewhere in the mantle's slow churn, entire eons dissolve. Mountains that stood for 100 million years return to liquid heat. Coastlines that cradled the first complex life vanish beneath convergent plates, pulled down into the furnace where memory melts. If the planet remembers, it remembers the way water remembers light, by bending it, scattering it, letting it pass through, changed. The stone forgets its shape, the ocean forgets its shore, and in that forgetting, something else emerges. Not absence, but transformation. The earth does not erase by malice or accident, it erases because it is alive in the slowest sense, breathing through millennia, renewing itself by consuming what it once was. We stand on a surface that is always new, always thin, a skin of rock no older than a few 100 million years in most places, floating atop a planet 4.5 billion years old. Beneath us, the archive burns. Above us, rain begins the gentle work of washing it all away again. The question is not whether the earth keeps its history. The question is why it doesn't. And the answer may be the same reason a river does not carry every stone it has ever touched. Everything flows. Roughly 4 billion years ago, when the planet's crust first began to harden from an ocean of magma, there was no granite yet, no stable ground. The surface cooled in patches, thin islands of solid rock floating on a restless interior. Evidence suggests these earliest fragments, the protocontinents, geologists sometimes call them, were small, dark, and perpetually recycled. They did not last. Most researchers believe the violent churn of plate tectonics in Earth's infancy was even more aggressive than today, driven by a hotter interior and thinner lithosphere. Slabs of newborn crust buckled and sank within tens of millions of years, drawn back into the mantle's convective flow. What little solid ground existed was erased almost as quickly as it formed. The oldest known rocks on Earth's surface date back approximately 4 billion years. Tiny zircon crystals found in Western Australia, no larger than grains of sand. Yet these are fragments, not continents. They survived only because they were chemically resilient, small enough to be carried through geologic chaos without melting entirely. The vast majority of the Hadean Eon, Earth's first 600 million years, left almost no physical record. Geologists infer its conditions from indirect evidence, isotopes in those ancient zircons, models of planetary formation, comparisons with other rocky worlds. The story is written in absence. By 3.5 billion years ago, stable landmasses began to persist for longer spans. The cratons, ancient cores of continents, formed as volcanic arcs, collided and fused, their roots extending deep enough to resist subduction. Some of these cratons still exist today, embedded within modern continents like fossils of geography itself. The Canadian Shield, the Kaap Vaal Craton in South Africa, the Pilbara Craton in Australia. These ancient fragments offer rare windows into deep time, but even they have been transformed. Metamorphism, the slow cooking of rock under pressure and heat, alters mineral structures, resetting chemical clocks, overwriting the original story. A stone that began as sediment on an ancient seafloor might be compressed into schist, then partially melted into migmatite, its history layered over itself until the first chapter is unreadable. The engine of this erasure is plate tectonics, the grinding ballet of lithospheric slabs moving across the planet's surface. At mid-ocean ridges, new crust rises from the mantle, still hot, spreading outward in slow symmetry. At subduction zones, old crust bends downward and descends, pulled by its own cooling weight, into the mantle's convective embrace. Most geologists agree that the oldest oceanic crust currently on Earth's surface is no more than 200 million years old. Everything older has been consumed. The ocean floor is a conveyor belt with no reverse, a surface perpetually renewed by forgetting what came before. Continents endure longer, but they too are rewritten. Erosion is patient. Rain and wind freeze and thaw. The slow acids of organic decay. All of these carve away at high ground, grain by grain, carrying sediment toward the sea. Mountains rise through tectonic collision, then begin their descent the moment they appear. The Himalayas grow by millimeters each year, but they also shed millions of tons of rock, wash down the Ganges and Brahmaputra, spread across floodplains buried in deltas. In 10 million years, the peaks we see today will be gentler, their sharp youth softened. In 100 million years, they may be gone entirely, their atoms redistributed across new landscapes. Noon holds steady over ancient ground. It was not always this way, scientists believe. Early Earth may have operated under different rules. Some studies propose that before plate tectonics began in earnest, the planet's heat escaped through a different mechanism, perhaps through widespread volcanism, or through a process called stagnant lid tectonics, where the crust remained largely immobile. If so, the transition to modern plate tectonics would have been the moment Earth began its systematic self-erasure, trading permanence for renewal. The timing of this transition remains debated, with estimates ranging from 4 billion to 2.5 billion years ago. The evidence, predictably, has been mostly erased, and so we live on a surface that is always adolescent, geologically speaking. The ground beneath our feet is younger than the dinosaurs in most places, younger than the first forests, sometimes younger than the first humans. The very old stone, the 4 billion-year-old fragments, the ancient cratons, are rare exceptions, islands of deep time in a sea of recent revision. The rest is gone, not destroyed but transformed, cycled back through the mantle's heat, emerging elsewhere as new magma, new mountains, new shores. Perhaps this is why the Earth cannot tell us its full story, not because the story was never written, but because the pages are the ink, and the ink becomes the pages, and both dissolve into something else before the book can be finished. Yet beneath that stillness, beneath the cycle's hum, there is a question that data cannot answer. If the Earth erases itself, does it know what it forgets? When a slab of seafloor descends into the mantle, does the mantle remember it was once ocean? When a mountain weathers into sand, does the sand carry any trace of the peak it came from, beyond the chemistry of its minerals? Science can track isotopes and measure velocities. It can reconstruct ancient supercontinents from magnetic stripes in rock, date eruptions from layers of ash, but it cannot tell us what it feels like to be a planet that consumes its own past. Some researchers propose that Earth's self-erasure is not merely mechanical, but almost purposeful in function, though not in intent. By recycling its crust, the planet regulates its internal heat, maintains a magnetic field that shields life from solar wind, and keeps water cycling between the surface and the deep interior. Plate tectonics may be the reason Earth has remained habitable for billions of years, unlike Venus, which has no tectonic activity and became a furnace, or Mars, which lost its magnetic field and its atmosphere leaked into space. If this is true, then forgetting is not a flaw, but a feature, a kind of planetary metabolism where old rock is digested to sustain new life. And beyond what the data can show, there is something almost mythic in the image of a world that constantly revises itself. In ancient cosmologies, the Earth was often imagined as eternal, unchanging, the stable ground against which all else moved. But the geologic record tells a different story. A planet that has no permanent form, only phases. It has been a snowball, frozen from pole to equator at least twice. It has been a greenhouse, with palm trees growing in polar regions. It has had one supercontinent, then 7 smaller ones, then one again, over and over in a cycle called the Wilson cycle, repeating roughly every 500 million years. Each configuration erases the previous one, not entirely, but enough that reconstructing the past becomes an act of detective work, piecing together clues from scattered fragments. Perhaps the Earth was remembering itself in the only way it could, not through preservation, but through pattern. The same forces that destroyed the ancient mountains are building new ones. The same subduction zones that swallowed Panthalassa, the superocean, are consuming the Pacific today. The rhythm repeats, but the details change. Each iteration is unique, yet each follows the same deep grammar of heat and gravity, pressure and time. If there is a memory, it is encoded not in the rocks themselves, but in the rules that shape them, the physics that governs their transformation. The planet remembers how to be a planet, even as it forgets what it has been. In the Archean Eon, roughly 3 billion years ago, the continents were smaller and the seas were vast. The atmosphere held almost no oxygen. Stromatolites, layered mounds built by cyanobacteria, dotted shallow coastlines, beginning the slow work of photosynthesis that would eventually transform the air. These bacterial colonies created some of the oldest visible fossils, preserved in rare sedimentary formations that escaped subduction and metamorphism. But the world they inhabited is almost entirely gone. The shores they lined have been subducted. The ocean chemistry has changed. Even the day was shorter then, perhaps 20 hours long, as the moon's gravitational drag gradually slowed Earth's rotation. The sky held a larger moon, closer to Earth, pulling stronger tides across shallower seas. The Great Oxidation Event, around 2.5 billion years ago, marked a turning point. Oxygen began to accumulate in the atmosphere, a waste product of photosynthesis that poisoned many anaerobic organisms but opened ecological space for new forms of complexity. Evidence from banded iron formations suggests this happened in pulses, oxygenation advancing and retreating over millions of years. The iron in Earth's ancient oceans rusted and sank, creating vast sedimentary deposits that we mine today for steel. This is one of the few ways the deep past remains legible, not as landscape, but as resource, buried treasure that testifies to atmospheric revolution. The rust layers speak of a catastrophe that was also a threshold, a mass extinction that enabled everything that followed. Time breathes outward, and then came the supercontinents. Rodinia assembled roughly 1 billion years ago, a single landmass that gathered most of Earth's crust into one place. Geologists infer its existence from matching rock formations on continents now separated by oceans, from the ages of mountain belts that mark ancient collisions, from paleomagnetic data that traces how fragments have wandered. Rodinia did not last. It began to rift apart around 750 million years ago, and in its fragmentation, something extraordinary may have occurred. Some studies propose that the breakup triggered a series of extreme glaciations, periods when ice covered nearly the entire planet. The snowball Earth hypothesis suggests that Earth froze so thoroughly that only volcanic activity releasing carbon dioxide from beneath the ice eventually warmed the planet enough to thaw. And if this happened, and the evidence is still debated, then the erasure became almost total. Ice sheets, kilometers thick, scoured the continents, grinding down mountains, obliterating river valleys, burying forests of algae and early multicellular life beneath advancing glaciers. When the ice finally retreated, the landscape was reset. What came after was not a continuation, but a new beginning. The Ediacaran period saw the rise of the first large complex organisms, strange frond-like creatures preserved in rare fossil beds. These too would largely vanish, replaced in the Cambrian explosion by the ancestors of most modern animal groups. Each turnover erased the previous ecology, not through malice, but through the same relentless cycling that erases mountains. Perhaps the Earth was never trying to keep a record. Perhaps the idea of preservation is a human projection, born from our need for narrative continuity, for the comfort of knowing where we came from. Stone does not grieve its transformation. Continents do not mourn their lost configurations. The mantle does not weep for the crust it consumes. Erasure is simply motion. The planet is not a library, but a river. and rivers do not stop flowing to save the water that has already passed. The current moves forward because that is what currents do, indifferent to sentiment, faithful only to gravity and slope. And yet we find fragments. In a canyon wall in Australia, a layer of ancient sediment preserves ripples made by water 3 billion years ago, frozen in time by rapid burial and gentle pressure. In Greenland, pillow basalts, lava that cooled underwater, testify to volcanic eruptions when the North Atlantic did not yet exist. In South Africa, a meteorite impact crater 2 billion years old marks a day when the sky fell, and the crater still shows the shattered rock, the melt structures, the evidence of catastrophic energy release. These are the exceptions, the lucky survivors, the pages that did not burn. But for every page that survives, 1,000 do not. For every fossil that forms, 10,000 organisms decay without trace. For every rock that endures metamorphism and erosion and subduction, 1,000,000 are ground to powder, melted to magma, dispersed as ash. The Earth's history is not a book with missing pages. It is a book that is being written, erased, and rewritten simultaneously, each new sentence partly composed of the letters from old ones. It may be more honest to imagine the planet not as forgetting, but as composting. The past does not vanish, it becomes soil for the future. The atoms that once formed Pangaea's mountains are now distributed across every continent. The calcium in our bones may have cycled through ancient coral reefs, through limestone cliffs, through the shells of Cretaceous ammonites, through the teeth of mosasaurs that hunted shallow Mesozoic seas. We are made of revised material, our bodies temporary arrangements of elements that have been many things before and will be many things after. In this sense, the erasure is not loss, but participation. The planet does not archive its history outside itself. It becomes its history, over and over, in endless recombination. The subduction zones that ring the Pacific, the so-called Ring of Fire, process roughly 3 square kilometers of seafloor every year, pulling ancient ocean bottom into the mantle at the pace of fingernail growth. This descent is not instantaneous. The slab sinks slowly, taking millions of years to reach the deep mantle, and along the way it releases water trapped in its minerals. This water rises, lowering the melting point of the mantle above, generating the magma that feeds volcanic arcs. The Andes, the Cascades, the islands of Japan and Indonesia. What was once seafloor becomes mountain. What was once horizontal becomes vertical. The transformation is complete, yet the atoms remain shuffled into new arrangements, playing new roles in the planetary metabolism. Elsewhere, where continents collide, a different kind of erasure unfolds. The Himalayas rise because the Indian plate is pushing into the Eurasian plate, and neither will subduct. Continental crust is too buoyant, too light to sink. Instead, the crust crumples, thickens, rises. But this process also buries vast quantities of rock deep beneath the surface, where pressure and heat transform limestone into marble, shale into slate, granite into gneiss. The original identity of these rocks becomes ambiguous, overwritten by metamorphic revision. A geologist might identify the parent rock through careful analysis, but the stone itself no longer resembles what it was. The mountain building is also a kind of forgetting, an erasure through transformation rather than removal. Dusk settles over the ledger of stone. When stone forgets its shape, does it remember heat? When the seafloor descends into the mantle, does it carry with it the weight of the water it once held? These are not scientific questions, but they gesture towards something science acknowledges, that the boundary between destruction and creation is thinner than we imagine. Every act of erasure is also an act of potential. The continent that subducts today may rise as a volcanic arc in 50 million years. The mountain that erodes today may become a sandstone cliff in 100 million years, its grains compacted into new stone, its story continued in a different grammar. The ocean that evaporates today may fall as rain on a mountain range that does not yet exist, carving valleys that will one day hold rivers we cannot name. Oceans rose, continents wandered, time kept breathing, and in the breathing, nothing was lost, only changed. The earth has no archive because it is the archive, perpetually unfolding, each layer a revision of the last. We who walk its surface are temporary witnesses to one moment in an endless revision, one frame in a film that has been playing for 4.5 billion years and will continue long after our portion of the film degrades and is overwritten. Our cities will become sediment layers. Our roads will become fossil traces, thin lines of compacted aggregate and asphalt that some future geologist might puzzle over, wondering what organism made such linear structures. Our plastics will persist longer than our bones, scattered through sedimentary formations like the carbon-rich layers that mark ancient forests. There is a humility in this. The planet does not need us to remember it. It remembers itself through transformation, through the act of becoming what it is about to be. The magnetic field records its own reversals in cooling lava, a memory encoded in iron alignment that flips polarity every few 100,000 years on average, though the timing is irregular, unpredictable. The fossils we find are accidents of preservation, moments when conditions aligned to save something from the cycle, but the cycle is the rule, and the fossils are the exception. Most of life has left no trace, and most of Earth's history exists only as inference, as ghost, as the shape of a gap where something used to be. Yet we are here, with our instruments and our curiosity, reconstructing the past from clues written in vanishing ink. We drill ice cores that hold atmospheres from 100,000 years ago, bubbles of ancient air trapped in crystalline memory. We measure isotopes that reveal the temperature of oceans long evaporated. We trace the paths of continents by matching fossils across separated shores, by reading the magnetic stripes on the ocean floor like tree rings. We date volcanic ash layers by the decay of radioactive elements, establishing timelines that reach back hundreds of millions of years. The work is patient, accumulative, reverent. We are learning to read a text that is being erased as we read it, and perhaps that is the only kind of reading that matters, the kind that acknowledges its own impermanence, its own place in the cycle of revision. The Appalachian Mountains were once as tall as the Himalayas, formed when the supercontinent Pangaea assembled around 300 million years ago. They have been eroding ever since. Each year, rivers carry away a thin layer, distributing sediment across the coastal plains, building deltas at the mouths of rivers, extending the shoreline grain by grain. In another 100 million years, the Appalachians may be gentle hills, their rocks exposed by erosion, their internal structure laid bare for inspection. But by then, new mountains will be rising elsewhere, perhaps where the Atlantic Ocean is now, if the continents reverse their drift and begin to reconverge. The cycle does not end, it only changes location. In the end, the question may answer itself through silence. Why did the planet erase its own history? Because history for a planet is not a story to be kept, but a process to be continued. Because the ground is not a stage, but a participant, shaping and shaped by the life it holds, the water it cycles, the heat it releases. Because forgetting is another word for transformation, and transformation is the only constant in a world where the crust is thin, and the mantle is patient, and the core still burns with the heat of creation, with the residual warmth from Earth's formation, and the ongoing decay of radioactive elements deep within. The archive does not need to survive. It only needs to become, and perhaps that is enough. In the folding dark of ancient stone, the same silence that opened this journey hums a different tone now. Not absence, but presence. The presence of motion, of change, of time as a river that carries everything forward while dissolving the banks that gave it shape. Somewhere beneath the surface, old crust descends into heat, its minerals rearranging, its history becoming potential. Somewhere above, rain falls on new mountains, beginning the patient work of reduction, turning peaks into plains, cliffs into sand, stone into the soft accumulation that will, in time, become stone again. The circle closes, but it is not a circle. It is a spiral. Each turn similar to the last, but never quite the same, repeating without repetition, familiar yet strange. The light has dimmed completely now. Night wraps itself around the thought, around the image of a planet that rewrites itself endlessly, that cannot help but revise, because revision is survival, because a static Earth would be a dead Earth, frozen in one configuration until the sun expands and swallows it. Instead, our Earth moves, breathes, transforms. It gives up its past to secure its future. It forgets so that it can continue. The planet does not pause to reflect on what it has erased. It continues, breath by breath, plate by plate, the slow exhale of geologic time that sounds from a distance like the hush before sleep. The tectonic plates still drift at the speed fingernails grow. The rain still falls, the wind still sculpts, and beneath it all, the mantle still churns, still carries old crust down and lifts new magma up, still performs the ancient alchemy that turns ending into beginning. We who listen have reached the edge of the story, the place where explanation fades into acceptance. The Earth erases itself because that is what living systems do. They metabolize their own past, they adapt, they flow. There is no tragedy in this, only the deep grammar of renewal. The ground beneath us is not permanent, but it is present. The history is not preserved, but it is continuous. We are standing on a moment in the cycle, and the moment is enough. We are made of the same materials that have been cycling for billions of years, and we will return to that cycle, and something else will be made from what we were. The oceans hold their depth, the mantle holds its heat, the crust holds its thinness, its vulnerability, its readiness to be revised. And above it all, the atmosphere holds the breath we share with every organism that has ever lived on this surface, this temporary skin, this place where memory and forgetting are the same slow motion, the same patient work of transformation that never stops, never rests, never finishes its revision. In the dark, the earth keeps breathing. So do we.